Alright, so question 21 and 22 deal with a situation of general equilibrium analysis. Now, this in particular is a 3% two good economy where you have two goods X and Y, and the people all have Cobb-Douglas type utility functions, namely xy, x cubed y, and xy squared. Now, in any general equilibrium analysis, always it's the relative prices of the goods that matter. Which is to say that you can always set at least one of the prices equal to 1. So in this particular case, let's set the price of good Y to be 1 and let the price of good X be P. So Px upon Py, which is what the question asks us to determine, is simply P in our analysis. Now, so since the utility functions all involve X and Y and are well behaved, Cobb-Douglas, no less, in this particular case, you would always want to, if you have some money left over in your budget constraint, you would always want to buy a little more of either one good or the other. So in this particular case, all budget constraints will bind with equality. Now, what the budget constraints are will depend obviously on your endowments, and the endowments are the two questions differ, 21 and 22 differ only in terms of the endowments. The endowments are 2, 0, 0, 12, 12, 0 for question 21 and 0, 2, 12, 0, 0, 12 for question 22. Correspondingly, you have budget constraints of 2p, 12 and 12p for question 21 and 2, 12p and 12 for question 22. Now, so each person maximizes their own utility corresponding to their respective budget constraints according to the initial endowments. So let's look at the case of the first player first. So he maximizes xy, which is the Cobb-Douglas utility function with equal weights, subject to the budget constraint that px plus y equal to say 2p or p2. Now, when you have Cobb-Douglas utility function with equal weights, that is xy or x half y half, in that case you want to eventually, there's this little trick with regard to Cobb-Douglas utility functions. You always want to spend on goods your budget in a ratio. Let's say your Cobb-Douglas utility function is x raised to alpha, y raised to beta. You would spend your budget on goods x and y in the ratio alpha is to beta. In this particular case, given the utility function xy, you would spend equal amounts on x and y. So in the first scenario, that comes out to mean that you spend exactly p on both goods, which is to say that your demand for x1 would be 1 and your demand for y1 would be p. Similarly, when you have 2 to spend, you spend it in equal amounts, so you spend 1 on each good, so x1 would be 1 by p and y1 would be 1. Similarly, when you have 12 to spend and the ratio is 3 is to 1, you spend 3/4 of this on x2 and 1/4 on y2, so y2 would be 1/4 of 12, which is 3, and x2 you would be spending 3/4, which is 9, so x2 would be 9 by p. Similarly, you can solve for all values of x's and y's for all three people in both cases. Now, once you get these values, there is another constraint remaining, which is to say that the final allocations of any good must be exactly equal to the initial endowments of that, which gives you the constraints that x1 plus x2 plus x3 should be 14 in case 21, question 21, and 12 in case question 22, and y1 plus y2 plus y3 must similarly be 12 in question 21 and 14 in question 22. Now, so substituting back the values of x1, x2, x3, y1, y2, y3 into these two equations, you get the value of p. Just make sure that you double check by getting the values of p from both these constraints. Make sure that they equal. It's to be noted that in a Cobb-Douglas type utility function, since here all agents have Cobb-Douglas utility functions, you will necessarily get an equilibrium. But if the utility functions are different, that might not be the case. Now, the point is, just double check. And in this particular case, for question 21, you will get a price of 1 giving you an equilibrium, and in the case of question 22, it will be a price of 5 by 3. So question 21, the price ratio is 1, and for question 22, the price ratio is greater than 1.